So the experiment design, is part belong to the statistics. So what's the major content of the statistics? What is statistics about? Anybody have any idea? So sometimes in Chinese, actually, there are 6 words. It's one is 抽样 sampling, another one is 估计 estimation, and another one is 推断 interference. So these are the 3 words. You need to remember. About that's the major content of statistics. Basically, it's the sampling, estimation, and the test. So this course, the experiment design actually tell us, how to collect data, how to do the sampling. It's more relevant to the sampling. But the sampling is different, to different scientific area. In the social society study, they randomly draw a sample from a big population and do some investigation. But for agriculture and biology, we need to do some experiment, either in the field or in the lab. So the basic idea to do the experiment is to collect the data. So in the design, actually, we have 2 sampling steps. So first, we need to sample our material, what material we are going to use, to do the field test. Another one actually is about the environment, because the phenotype, the yield, the different maturity traits is different in different environment. So in the experiment, actually, we need to know that, then the sampling, both the material and the environment should be representative. So I will come back to that again. So as far as this the design, so the Fis He, made the biggest contribution to the design. I think everyone in this class will know who Fis He is. No? We know the FF distribution. Yes? We know analysis of analysis of variance. The F distribution, F actually is the first letter of Fis He's name. So because that distribution was invented by Fis He, and also the analysis of variance. If you have a statistical book, if you take away the ANOVA, maybe the book can be reduced by half. So the ANOVA is the major statistical method, that not just used in agriculture, biology, but also in many social studies. So Fis He, as far as I know, was born in UK, and I think was grew up in India for he studied there for many years and then come back to UK. So the experiment design actually come from his more than 10 years of work at the Rothamsted Station. So this station is well known in the world, that they have a long-term experiment on the soil fertility in the field. So this station actually was founded in 1843. So basically, when Fis He joined this station, the experiment there had been run for many years. There are a lot of data. So before Fis He, came to Rothamsted, the people, we don't have the idea to how to do the experiment. The experiment is more or less, there's no rule to follow. It's more or less arbitrary. So Fis He is a mathematician. So he take a deep look at this data and proposed, some basic principles we are using today, which is the local control, replication, and randomization. So these are the three major principles, applicable basically to any design. So we needed to take this into consideration, when you make your experiment in the future. But Fis He, did much more than experiment design. Actually, his most of the contribution is to the statistics. So he wrote a book called The Statistical Principle for Research Workers. The first version was published in 1925. So this book actually had been published more than 10 versions, before Fis He died. So he has another book, of course, on the design of experiment. So I bring this book. Actually, these three books, they are three separate books at Fis He the time. And years ago, I think it's Oxford, it's Oxford science publication. They put the three books together. Of course, the three latest version. So as you can see here, first one is about we call the statistical method. As you can see, we call the estimation. How we do the estimation from the data we have. So the second one is on the design. So the third one is on the interface. So basically, it's very straightforward. To do any analysis, first we need to have the data. We need to have the good data. Once we have the data, we need to know how to analyze the data. Once we have some results, we need to make some inference, whether the new variety is better than the older variety, whether the frequencies in two populations are equal or not. So we wanted to, there are some hypotheses we wanted to test. So that's why I said, these are the three words, if you remember the three words after today, I think we are succeed for the first class. So the sampling for us to have the data. So sometimes to have the data, we need to make the experiment. Once we have the data, we do the estimation. So the estimation, of course, to estimate something we don't know yet. Before we make any experiment, there are always something we don't know. There are some, true value. Let's say for a wheat variety. Of course, it have a true yield and a given environment that we don't know yet. The data we have, we call the observed data. So a lot of, parameters, maybe we never know what the true value is. But we are not happy with that. We want to know. So we can make an estimate, from the experiment. So the third one is the inference. So remember that. So I have this book with me. It's quite heavy, but I read it at least 2 times, from the beginning to the end. I don't recommend that you read it. But if you really want, you can. I bought this from Amazon years ago, because the Fis He is a theoretical, mathematician. A lot of the text maybe it's not that easy for the biological scientists to understand. There are some textbook which are more maybe more easier to understand. Okay, so before we do the experiment, so we also need to know, what are the sources of errors or the variations. So the variation, can come from individual plant in the field. So basically, that variation can reflect the variation in the soil. So even the same genotype or the same variety, different individual can have a different performance due to the soil condition or the competition and the plot the variation. So they also the variation between different seasons, even at the same location. Different year can have a different rainfall, different weather condition. So the seasonal variation is also great from year to year. And the soil viability. So when we make the experiment, we need to reduce the random errors, as much as we can, so that, ideally, if there's no random error, the data we observed will reflect the true value. But in agriculture, it's in biology many times, we cannot avoid the random error completely. There's always some errors associated. What we can do, is to reduce. We can for the experiment set. If we do the experiment in a well-managed field, the error will be low. If we randomly choose a field which is very much, is not uniform in soil condition, in water condition, the random error will be large. So what we can do, is to reduce the error, so the data what we observed will be more close to the true value. The local control, actually, we need to select, so the block, the idea of the block actually is to do the local control. Sometimes we cannot have a piece of land which is uniform for all replications. So we can have one replication here, which is uniform. We can have another replication there, which is uniform as well. But the two area of land, can be different. So these are the, by using the block, we can reduce the experiment, the error. So another criteria to make the block, is to consider, the two blocks shouldn't be far away, and there are some time consideration and management consideration as well. So how we know if we have a piece of land, how we know, whether the piece of land is uniform or not. So ideally, before we do, a formal experiment, we need to make a preliminary experiment, which is called the uniformity trial. So which means, suppose this is a piece of land, so we grow the same material or the same variety. The only difference at the same time by using the same management. So the only difference is the soil condition. So every year we have the same variety, we give it the same amount of water, the plant was growing, under the same management condition. So the variation we observed, more or less reflect the variation of the soil. So the soil in this area actually is quite uniform, and we have other area uniform, but there are some variations from here up to here. So by making this experiment, we can have a rough idea, if we have our experiment in this piece of land, the random error will be controlled, will be small. So if you choose, this area of land, the random error, will be great. So if this piece of land cannot, allow us to have all replications, so we can have one replication here, maybe another replication in this area. So that also works. That's what we exactly call the block control. So the difference between blocks, can happen. Here are some general steps we can follow. So as for any scientific research, we need to clear what's our target, what we are going to achieve through a research or through the experiment. So whether we are going to compare the yield from different variety, or we want to study the efficiency from different managements, or from different fertilizer, or from different planting date. Also, many times we do genetic study. Now, a lot of genetic study, we also need to make the field experiment to collect the data. So, different experiment can different objective. So, firstly, we need to be clear what our objective is to make this experiment, and then we choose what are our treatment. So the treatment sometimes can just form one factor. We wanted to compare, the difference from variety under the same condition. But sometimes, we have to consider, the two factors or three factors. And then we select, the experiment material. Let's say we wanted to compare 10 varieties. What are the 10 varieties? There may be many. We wanted to study the genetic variation of the wheat genetic resources. So how we draw the sample? So that's we need to select the material to do the experiment, and what design. I will say still the complete block design is mostly designed in biology and in agriculture. But in breeding, many times, because we have a lot of genotype, there are some other design we can use. But mostly, if we have the treatment number is not too much, not too much, I mean we only have 50, maybe less than 100, probably still the complete block design is the best one we can choose. And then we need to decide, what's the unit to make the observation. So some trait, can be measured based on each plot, like maturity. Sometimes, the data can only be measured by individual plant. Let's say the plant height or maturity. So basically, we can measure, a number of plants in one plot and, do some average. So this we need to consider, what a variable or what a trait we are going to measure. And we need to know how to control, the adjacent, the neighboring, the effect or the border effect. And what kind of data to collect. Some data may be continuous, some data may be discrete. So we need to make a plan when to record which kind of data. And outline the statistical analysis. So basically, before we do the experiment, we should have the rough idea what statistical analysis method we are going to use. It's not like that, we don't have any idea. We just, to find the method when after we have the data. But sometimes it's okay, but sometimes it's maybe too late. And followed, by the conduction of the experiment. So some experiment can last for several months. Let's say if we do the yield trial on wheat, the winter wheat may take 8 months. So some crop at least a few months. So we need to, take care of the experiment, during the whole procedure. And finally, we collect the data, we analyze the data, we have some results and try to explain the results. And then we prepare, a report. And sometimes, if we do graduate study, we wanted to write a journal article, So especially if you want to publish your results, if you don't use any statistical analysis, it's almost impossible to have it published in these days. So what is a well-planned experiment? So firstly, it should be as simple as possible. So we cannot, expect to solve all problem, in one experiment. Sometimes we have a big problem, we can separate the problem into different small problem. So one experiment normally, cannot solve all the problem. And if we consider too many factors in one experiment, in the end, maybe we cannot draw any concrete, conclusion. And we need to have a very clear objective, to achieve. And the experiment should have some degree of precision, or to use some design, with sufficient replication. So the more replication we have, actually, the replication we can have estimated mean called the sample mean. So the variance of the sample mean, will be smaller if we have more replications. So the smaller of the sample mean, which means the sample mean will be more closer to the true value. So the replication, not only allow us to estimate the error variance, but also, reduce the variance in the sample mean, which is always used to estimate the population mean. And we should avoid, the systematic error. Systematic error, is not terrible, but we still, want to avoid it. Let's say, we measure the weight of different objects. Maybe the equipment, give us the value always 10 kilometers to 10 kilogram here. It's not a big problem, to compare the difference, but many times we still want to avoid that. For example, to measure to collect data in the field, if one person cannot collect all the replication, so we can have, one person to collect data in one replication, and another person to collect data in a second replication, and the third pupil to collect data in the third replication. So it's not good, you arrange one person to collect data in all replication for part of the treatment, but another person, for another part. Because, if we measure the plant head, well, we human people, we know the head should be from bottom to the end, but somebody may say, oh, this is the end, but you will say, no, that's not, you should go a little bit here. All the maturity, we know the maturity for a block, the maturity should be the data where 50% of material, flowered or mature. So the 50% is by eye. You may say, oh, this is the 50 already, but I may say, well, not yet. Or, it's more than 50. So that's why, that's if we have a different person to take care of different replication, there may be some systematic error, but which cannot make a difference to the analysis. So and have a range of validity of the conclusion. So we to have sometimes we, as I said, we do sense. We want to have, make a research, we can have some results, which have a wider application. The wider the application, the more valuable, right? If you make one experiment, your conclusion is very specific. If you measure the yield only under a very special condition in the lab or in the greenhouse, it doesn't mean that conclusion cannot be extended to the field. So that the conclusion is the value of the conclusion is limited. So to do that, we need to our material should be representative. Or as I said, the environmental set, the location, or the field management should be representative as well. And then our conclusion, can have a wider application. And be able to calculate degree of uncertainty. Basically here, is the degree of the degree of freedom for the errors. So to have a replication, we can do that. So now we have talk about some terminologies. From the largest to the smallest. So first one is the whole experiment. So it's we use a set of material, we use a set of treatments, we make select one location or more location, and we collect data. The whole thing we call is an experiment. So in this experiment, we can have some treatment, all the factors. If we only have one factor, the factor should have at least the 2 levels. Of course, it can have more than 2. So like before we mentioned the weight of mutant. The mutant is a factor. So the favor varieties represent the favor levels within this factor. So the favor levels, if we have only one factor, actually represent the favor treatment. So if we have 2 factors, one treatment actually is a combination of the levels from the 2 factors. So the second is level. So each factor, can take different values. And then it's experiment unit. So experiment unit basically is in the field represent one treatment and one replication. So basically the plot. So each plot, we grow one material or one treatment and one replication. So that's the very basic unit. So based on this unit, we do the design or we collect the data. So after that is block. Block actually is a set of experiment units, or a set of the set of plots. So it's a set of plots. So many times, we can use the complete block. Complete block, which means, all treatment appear once and only once in that block. So we call it a complete block. So we have a complete block, then sometimes we make some incomplete block. So which means, the plot, the block is not large enough to have the whole replication. So it just have a part of the replication. That's called incomplete block. So the block can be equal with to the replication, or can be smaller than one replication for in the case of incomplete block. And then the sampling unit. Sampling unit is basically it's how we collect the data. So as I said, the green yield, of course, we measure the green yield, for the whole plot. But there are some traits we, actually is individual based, and then we do some average. and the variable. So variable, which means the some characters we are going to measure. Okay, replication. So which means the number of treatment appeared in our experiment. So that's the replication. Experiment error is equivalent to the random error. So in the phenotypic data, of course, there's some true value there, but there's also some random error from some factors we cannot control. Let's say if we grew one variety, in the same area of plot for 3 times, the 3 block will give us a different yield, very likely. So the variation, from the replication represent the variation of the random error. So we come back to the 3 principal design. So it's local control. So it's better to arrange, the one replication in one block, another replication in another block, so that we can reduce the random error in the field. So we need to clear to make the good experiment. We want to achieve the data which is accurate and precise. There's some little bit of difference between the accuracy and the precision. So the accuracy, which means the observed data is closer to the true value. So for example, here, if the true value is 10, the 3 of the value, they are all close. For this one, maybe the average is also 10, but the variation between these 3 of the data may be much larger than from this one. So we can say that these 3 of the data has a higher accuracy, and these 3, have a lower accuracy. So the high precision, which means the variation is small. But if we calculate the mean maybe is not equal to the true value. So this can be, this 3 data also maybe have the similar variation as this 3, but this 3 is more closer to the true value, but this 3 may have some systematic error. So we see this data, have a higher precision, and this data have a higher accuracy. So from this small data set, you can see the difference between accuracy and precision. Accuracy basically is more closer to the true value, and also the variation is small. So the high precision is just that the variation is small. There may be some system errors. Okay, the randomization. The replication. Okay.